everyone, I'm Nick. I'm an engineer at Arcium, and today we'll be talking about how MPC and blockchains are a match made in heaven and expand a little bit on what they can both bring to each other. So getting right into it, what can MPC bring to blockchain? So blockchains have been a huge step forward in bringing this kind of global ledger or global state to us, and that's earned them a reputation for being these sort of world computers. But they're not really like computers, right? I don't know about your computer, but mine doesn't show every single person on Earth what I have been doing in general. So that's kind of a loss of privacy that makes them very different. And on top of that loss of privacy, you can also get some adversarial behavior like MEV, where having this fully public allows people to copy your orders or do stuff that you generally wouldn't want them to. There's been several solutions put forward for this, and specifically for token transfers, this is pretty much solved. We have private blockchains for this. But for general logic, we're not quite there yet. There's been also solutions that have been put forward, but these rely on ZK and FHE typically to achieve this sort of behavior. But these technologies are incomplete on their own. They don't offer everything we want generally. And so you often have to put them together, which ends up being extremely expensive. On the other hand, when you're talking about shared computation and shared state, MPC is kind of the natural fit. It's literally computing on shared state. So MPC, when you try to apply to this problem, can really bring you this full threshold privacy, privacy of inputs, privacy of state, and minimize your trust assumptions. That in turn allows you to do all these cool applications like private DEXs, private AI on-chain, without any loss of privacy like you would in typical blockchains. So on the other hand, what can blockchains bring to MPC? MPC is a very complex protocol. It's very powerful, but it requires a lot of coordination between all the people participating. That can lead to these open problems that we have yet to really definitively solve. If you have several parties computing together, okay, who tells them to start a computation? What do you do if there is some kind of malicious activity, if this guy decides to just deviate from the protocol? What incentives are there for people to actually participate in this protocol? And many MPC solutions have relied on these kind of trusted parties in the center that end up giving a lot of direction to these peers participating and ends up basically centralizing a solution that at its heart is supposed to be decentralized. On the other hand, Arcium, because it's this sort of on-chain MPC marketplace, can rely on game theory and economics to kind of solve these problems. It also relies on blockchain as this sort of source of truth that is trustless. So the peers can directly refer to the blockchain instead of the centralized party, eliminating this centralization problem. And incentives and these malicious behaviors can be minimized or even eliminated using game theory and economics that are at the heart of the Arcium programs. So in the end, what you get is that blockchains get programmable privacy and security. MPC gets this central source of truth that eliminates a lot of the problems associated with it and really lets it focus on what it does best. So if you want to learn more about how Arcium combines MPC and blockchains to get this result, we'll leave links to our docs and other videos in the comments. And yeah, that was it. Thanks for tuning in.